talk to you about scientific notation. Many scientists and mathematicians use this notation to note very small and very large numbers. It is much easier to represent these numbers in this way than to write a large amount of consecutive zeros in the front or the back of each digit. So let's look at the rule. The rule says that A has to be between 1 and 10. So let's take a look at our numbers. How do I turn 510,000 into scientific notation? It's very simple. Since this is a big number, we're going to start at the decimal place and go to the left. We count the spaces in between. 1, 2, 3, 4, 5. Now, since our number has it between 1 and 10, I'm going to take 5.1 and raise it to 10 to the 5th power. We counted 5 spaces. It's a big number, so it's going to have a positive exponent of 5. Now, what if we have a small number? Well, we just do the opposite. Starting at our decimal point again, this time we'll go to the right. 1, 2, 3. So I counted 3 spaces when I got to the first digit. So this is going to be 1.7 times 10 to the negative 3 power. Why negative 3? Because this is a very small number. When it's a small number, we always raise it to a negative exponent. When it's a large number, we raise it to the positive exponent, all based on how many spaces we count from the decimal point. So now that we know how to turn real numbers into scientific notation, how do I go from scientific notation to real numbers? Well, it's real simple. We just do the opposite of what we just did. This time, we're going to move our decimal point 4 spaces. Why? Because this is raised to the 4th power. Since it's raised to the 4th power, we know it's going to be a large number, so we'll go ahead and start with the 3 and add our zeros. So we have 3 here. We're going to add 1, 2, 3, 4 zeros. That gives us 30,000. Now notice if I count back, I should get the same number in scientific notation. Let's see. 1, 2, 3, 4. That's right. 3.0 times 10 to the 4th power is 30,000. Great. Just one more to go. So now I see that I have a negative 1. That tells me this is a very small number. So, since 2.6 is raised to the negative 1, I'm going to move the decimal spaces to the left. Since this is just 1, we're only going to move it 1 space. So that's going to give me 0.26. Let's check. 1 space is right between the 2 and the 6, right? So we know it's correct. And that's how we use scientific notation.